Hi, I'm Ryan Nickel, CTO at DSA Ocean, and today I want to talk about setting up an advanced towing scenario. So if you want to get some ship motions involved in assessing what a tow line is doing, one way to do this is with a rigid body and a motion RAO. We're going to work with some existing tutorial files to help with this. So if you're in ProteusDS Simulation Toolbox and you go to Help and View Tutorials, you'll see a tutorial on using an RAO database feature, and in this scenario it uses the generic frigate with a motion RAO database already configured. The input files are downloadable and they're under the folder PDS-ABV. So I've already downloaded those and run a little scenario. You can see that just in this short little scenario here, the frigate advances and follows some waves in there. So what we want to do is just add a tow line to this. That way you'll get some surface motion driving the tow line, and then also you can use scheduled turning and forward speed changes with the surface vessel. So what we're going to do is we're actually going to make a copy of this. So I've got the files in the input, and I'm going to copy all of these and just save them in here. And I'm going to work with a copy of these files. So bring up my visualizer, turn on the water surface here. Great. So we need to make a cable tow line. So we're going to go cable. I call this tow line. Create. In the project files, you may need to create the tow line properties. You can make them directly. Go to Add Feature, Decable Segment. We'll call this tow line properties. I'm for the most part, I'm going to leave these the same. I might make it a little heavier to represent something a little bit heavier, like wire, rope, umbilical kind of properties. But I'm just going to otherwise leave everything the same for now. The other thing we'll need to do is add a tow body itself. If you looked at the simple approach, we used an XMAS for that to just get started. I'm going to rename this tow body. And then we right-click, go to Feature Definition. Since this isn't in the library either, we'll have to create it. And I'm going to make it, I'm going to leave everything this default values, but I'm going to give it a bit of heavy density just so that it helps sync the tow line a little bit. I'll make this tow line, I will leave it like 100 meters just arbitrarily as we had done before. We need to set the state for the tow line. So we'll go to Edit, change the geometry length to be 100. And to give it some reasonable kind of starting position, I want to give it maybe something like 80 and 20 off the back. Okay, might need to adjust that. We'll go resolve because now we need to set the element lengths, the material properties. Go resolve. Again, a couple more elements. Okay, we haven't set a connection to the rigid body, and we're going to have to do that. So now what we'll do is we'll click on the connection button. The master in this case is going to be the rigid body, and the only option, this is the only way that they're configured to work. So we'll go to tow line, and then connection point, type point is what we want to do. And here now we need to specify, is it controlling node N? It is not. It's going to be controlling node 0. That's just the way I want to set it up. And then the generic frigate is a pretty big rigid body. Relative to the CG, the aft location is a fair ways back in the X direction, and we're going to put it a little bit above that. So now it won't live update the node connection position, but we can do that through the state. If we go back to the geometry, there's this handy button here, match connection. So we'll do that, and that will put the node back here. It's best if we update the deltas again, delta 80 and then 20 off the back. I think that should say negative 80. There we go. That's what I was looking for, this blue line. Like that's the geometry we're aiming for. And then we don't need to change the element lengths for material properties. We'll just go apply. That looks much better. Okay, so this is node 0 that's constrained to the back of the ship, and then we've got our tow body weight on the end here. So we'll go save. I will, let's see, we don't have any current profile, and that's perfect. The frigate control, we're not going to make any changes to this. This is something you can play with in your own scenario. So let's hit play and see how this goes. So again, the advantage of this is that the ship motion is going to be following, you know, the wave effects, and with an RAO database, you'll also be able to schedule forward speed changes and turning maneuvers and things like that. So you get into quite a lot more advanced scenarios. What I'm going to do here is pause it, and then I'm just going to peek on the progress in ProteusDS to see what it looks like. Alright, so there is our frigate, and there's going to be a transient effect as, let's turn on engineering mode so we can kind of see, I can see the element nodes there as well. So this point's fixed on the rigid body frame, and the waves are starting to ramp up. As the rigid body drives away, you can right-click on it in ProteusDS and go lock camera on this object, and it'll kind of follow along. That's quite a nice feature while ships are driving around. So you can see the waves are starting to ramp up and drive the surface motion of the tow line, as well as that forward speed effect. So another way to set up a tow scenario with a lot more detail than just the simple scenario. So thanks for watching.